right, we can use vectors to represent forces. So this would be a place, an application of these things in physics. So for our first example here, we've got forces of 12 pounds and 15 pounds that, this is bad English, act on an object, just ignore that word, act on an object at an angle of 42 degrees with each other. We are to find the magnitude of the resultant force. So we're looking at what the actual force is that's being acted on that object. So here's the process to do that. We're going to draw a geometric representation of those vectors, and then we'll find the resultant vector, which is the sum of the two vectors. So I'm going to start off actually by drawing the two vectors. I'm going to have their tails together. So I'm going to make one of them look like it's 12 and the other one look like it's 15, and the angle between them needs to be 42 degrees. So with that, I'm going to make that angle look like it's about 42, maybe about like that. That's pretty close. And what I mean by making one of them look like it's 12 and one of them look like it's 15 is really it's just the relationship between the two of them. So whichever one of these is shorter, I'm going to say is the 12, and the other one is going to be the 15. And this is 12 pounds of force and 15 pounds of force. And then I'll label this angle here 42 degrees. Now to sum these two vectors, as we learned in our lesson yesterday, you have to add one of them to the other by starting the tail of it on the head of the other one. So I'm going to use one of the vectors that's here already. I think I'll use the bottom one. And then I'm going to add the 12-pound vector to the head of that one. So I'm just going to kind of make a vector that's parallel to the one that was over there, the original 12-pound vector. And then I'll connect the tail of where the two of them started to the head of this one here. And that one is my resultant vector. I'm going to call it R for resultant vector. And that's actually the value that I'm looking for there. So let me label a couple other things here. Since this pink one was just a repeat of that 12-pound vector, its magnitude is 12 also. The angle that I have that I know is 42 degrees, but that one's not within this triangle that was formed here. What I would really like to know is this angle right there. Now the relationship between the angle that I know, that 42-degree angle, and this one over here, because they are same side interior angles on parallel lines, that means that they are supplementary angles, which means if you add them together, they have to equal 180. So I can use that fact to figure out that this angle right here is 138 degrees. So now I'm looking at this triangle here. This time I'm not dealing with a right triangle, so Pythagorean theorem is not going to be helpful. But recently we learned some other formulas that would help us. The case that we have on this one is side angle side. I do not have an angle and a side that are related to each other. So that means law of sines is not going to work for me. I would have to use law of cosines for this one. So I'm going to start off with law of cosines. So r is the side that I'm looking for. So that's r squared equals. And then it would be the other two sides filling in for the all of the other pieces of the law of cosines. So 15 squared plus 12 squared minus 2 times 15 times 12 times cosine of the angle across from the side that I'm looking for there. Okay, so now I need to get this in my calculator. I am solving for r, not for r squared. So when I put it in the calculator, I need to make sure I take the square root. And I found that working with these scientific calculators, it's helpful to use the fact that a square root and a power of 0.5 are the same. So I could put in all of this that's there and then raise it to the power of 0.5 and get the same effect as a square root. So I'll type all of that in my calculator, and my calculator says that that is 25.225 2, 9, 5, 8, 8, 5, 2, and it keeps going beyond that. We are going to round this to 3 decimal places. I wrote a bunch of them because I wanted to talk about proper rounding on this one. So since I want to round to 3 decimal places, that means that's as far as I want to go. But to decide how to round that last one, I need to look at the 4th place. And if that 4th place is a 5 or bigger, then that means I'm supposed to add 1 to the last spot that's there. And if it's 4 or less, then I just cut off the rest of the decimal and leave it like it is. Since this one is a 5, that means I have to round up. So that means that 9 would have to have 1 added to it, which makes it 10. So that's going to make it a 0, and I'm going to have to carry a 1 over to the next place. So this one, when properly rounded, would be 25.2, and then this is 1 plus 2, so 3, and then the last place would be a 0 there. Now in mathematics, when your decimal answer, rounded correctly as they asked you to, ends in a 0, you don't have to write that 0. But I believe if you were in a science class, you would have to actually write that 0 if you needed 5 significant figures for this one. I think they really only ever want 3, but they want all of those numbers, even if it's a 0 at the end there. So this one would be 25.23. That's the resultant force on the object. Okay, so let's try a second one here. And again, we've got bad English here because obviously I copy paste. Anyway, okay, so we've got forces of 21 pounds and 13 pounds that are acting on an object at an angle of 64 degrees with each other. Now, if you feel like you understood this concept, this would be a great time to pause the video and see if you can work this problem, and then come back and watch the rest of the video and see how you did. So here we go. So I'm going to start by drawing those 2 vectors. I'm going to draw one that looks like it's about 21. Then I'm going to make an angle of about 64 degrees. Oh, I need some direction there. Then another one that's 64 degrees rotation from that one. So I'm going to make it look about like that. And this one's supposed to be 13 pounds of pressure. So it should be considerably shorter than the first one. So I'm going to go ahead and label them. This one's 21 pounds. This one was 13 pounds. And then the angle between them is 64 degrees. Okay, so now I need to put in the resultant vector. And to do that, I have to add these 2 vectors together. So I'm going to recreate the 13-pound vector, starting it on the head of this 21-pound vector. I thought I changed the color on that, but it didn't turn out right. So anyway, so this one is 13 pounds still. Oops. 13 pounds. Okay, so now I'm going to connect the tail of the first one to the head of the last one, which again makes a triangle that is not a right triangle. But that new vector that I just drew in is my resultant vector, so that one's my r. Now again, I'm going to need this angle right here in order to find the value of r. And the relationship that it has with the angle that I know, that 64-degree angle. So if I add this new angle to 64, I have to get 180. So when I figure that out, that means that that angle right there would have to be 116 degrees. So now once again, I've got side angle side here, so I would use a law of cosines in order to find the value of r. So I'd say r squared is equal to 21 squared plus 13 squared minus 2 times 21 times 13 times cosine of 116 degrees. And so then I would put this in my calculator, and of course I'm solving for r, not r squared, so I need to make sure I take the square roots. And with that one, when rounded properly, I get 29.144. So my resultant force would be 29.144 pounds of pressure. All right, there are a couple questions on the Google form now for you to practice and see how you do.